another one. Just because the picture says so doesn't mean we necessarily have 4 square root of 95 as the largest side, but just to tell you the exact value, it would be roughly 38.98 for the distance of 4 square root of 95. So that would be our C value if we need to use it. We have then an application of a squared plus b squared equals c squared. We test out our legs. 15 squared plus 36 squared ends up being 521. 4 square root of 95 squared ends up being 520. Since those two values are not equal to each other, we do not have a right triangle based off the Pythagorean converse. So this triangle is not a right triangle because it fails that statement. Classifying triangles. Not only can we determine whether or not they are right triangles or not, we can determine if they are acute or obtuse triangles. So we know that the 3 types of triangles listed by their angles are right, obtuse, or acute, and we can now determine if the 2 legs of a triangle, a squared plus b squared, is greater than c squared, then the triangle is acute. On the flip side of that, at the bottom it says if a squared plus b squared is less than c squared, then the triangle, which in this case the example ABC, is obtuse. So now we can take 3 sides of a triangle, determine whether or not it is a triangle, and if it is a triangle for sure, then we can state whether it's an acute triangle, an obtuse triangle, or a right triangle. Right, acute, obtuse. 38, 77, 86. 3 sides of a triangle. Plugging it through the a squared, b squared, and c squared, we're left with a value of 7,373 is less than 7,396, so therefore obtuse triangle. On the right, we have 7, 6, and 5. Plugging it in, we have our 2 values, a squared and b squared, greater than 49, so therefore an acute triangle. Alright, next example here says classify the triangle. Given 3 points, the 3 points, A at 4, 5, B at -1, 7, and C at 3, 3. So we just talked about classifying triangles by their sides, and to do so we need to have their lengths, and then we can classify it as a right, obtuse, or acute based off of the Pythagorean Theorem setup. In order to find the lengths of the 3 sides, we need to do the distance formula between AB, BC, and CA. Again, the distance formula listed as D is equal to the square root of quantity x sub 1 minus x sub 2 quantity squared plus y sub 1 minus y sub 2 quantity squared. And filling in the information then as we go about it, we know that we can find that AB is the square root of 29. Expediting the process, we can also state after solving that BC is equal to the square root of, BC is equal to 4 square root of 2, and AC is equal to the square root of 5. Putting those 3 sides together with a squared, b squared, and c squared, we simplify and solve and find out that the a and b sides, the smaller of the 2, squared, add up together to be 34, which is greater than 32, which is the 3rd side squared, which then leaves the triangle to be acute. So this is a very fast explanation on this kind of tedious process. You first need to find, just recapping, you first need to find the lengths of all 3 sides using the distance formula. So repeating this process for BC and AC. I just gave you the results. Then determining which one's the largest of the 3. After looking at it, you would determine that this one is the largest of the 3. Then taking and doing your Pythagorean Theorem type work with it, where you're squaring the smaller 2 and adding them together, squaring the larger one, and then comparing the 2, and then from the comparison, distinguishing between acute or obtuse. Alright, last question is a proof. Proof states from the given that AB is equal to 4, BC is 2, and AC is equal to the square root of 10. we're trying to prove that angle 1 is acute. So let's find angle 1. Angle 1, we want to prove that this angle, we want to show or prove that this is an acute angle. Given to us are three values, and those three values are square root of 10, 4, and 2 for each one of the sides of the triangle. I would be safe to say that since we just talked about comparing the sides of a triangle to figure out what type of triangle it is, that we'd probably start there for the proof. Okay, given obviously comes first. If we don't have that stated, but further, we can state that triangle ABC is obtuse because if we square and compare, square root of 10 squared plus 2 squared is less than 4 squared. So therefore we have an obtuse triangle, right, as the two smaller sides add together less than the larger side. If we know we have an obtuse triangle, that means that one of the angles has to be an obtuse angle. Let's just try to say that again. If you have an obtuse triangle, one of your three angles has to be obtuse. So realistically, in the picture, either is going to be A, B, or C. One of those has to be an obtuse angle. The obtuse angle has to be across from the largest side. Since 4 is the largest side, C has to be the acute angle. Okay, and this is by just definition of an obtuse triangle. Okay, you have to have the obtuse angle across from the longest side. Otherwise, it doesn't work. It's not even an obtuse triangle. So if C is the obtuse angle, we know that both B, and it doesn't really matter, but we know that A and B have to be acute because the definition of an obtuse triangle. Okay, an obtuse definition of obtuse triangle says that you only have one obtuse angle in that triangle. So seeing as B, okay, is an acute angle, we can make a statement about angle 1 because angle 1 and angle B are congruent because of the definition of vertical angles. And if they're congruent because of vertical angles, then we know that 1 has to be acute by substitution, by saying if B is something, then 1 has to be something since they're congruent. So the key here, after we shown what type of triangle it was singling out that C had to be the obtuse angle, which means that A and B were acute angles, and since B and 1 were vertical angles, they obviously have to be the same. Good. That ends the lecture for today. Problems that we're going to look at from page 545, numbers 1 through 34, and 38 to 47. Thanks for watching.